So this was a hard question for me, and I was only able to make the connection when I noticed that 25 is 5 square, and then x square plus y square is 13 square, and then you see 13 times 5 is 65. So if I were to multiply these, so it's kind of hard to make this connection, honestly, or at least I struggled with it. And then you replace that here. And then you see what simplification happens, and that's what actually will eventually give you the result. But I don't think this is easy to do in the exam. And then this would become square of the first two terms plus twice their product. Now you'll see these two terms drop out, b squared y squared, and if I move that term to the other side, I get minus 2ax by equals 0. Now you have to pay attention that I can square these, and you'll see ay and bx are precisely here. You just have to kind of reorder them. And that means this is no different than square of this identity. And if that's equal to 0, that means ay minus bx, which is really k, is 0. So the answer is A, but I think this is a really hard question. I would probably just, if I weren't able to do it in the first shot, I'll just move on or maybe come back to it at the very end. I will kind of show you, you can stop watching the video here. Just wanted to show you the directions I went in, which is really linked to connecting these three terms. So for example, a plus x squared, I knew would give me a squared plus x squared plus 2ax. So I wanted to bring that in here, and then same with b plus y squared plus 2by, and then if I add them, I would get a squared plus x squared plus b squared plus y squared plus 2 times ax plus by. And I have a squared plus b squared, that's 25, this is 169, and then this is 2 times 65, so that became 130, 194, I end up with 324. So I just kind of end up here, it doesn't really lead me anywhere. I can kind of connect that as well, and I think that's what I tried to do. For example, you could do a plus y squared. So you're kind of just flipping, but you should be very comfortable with these identities. That I think is definitely useful in other questions. Minus 2bx. Now if you add them again, you would get this piece is just the sum of these two, 194, and then this is 2k. So I think I just kind of stalled here. Maybe there's another way out of this to kind of show you that k has to be 0, but I wasn't able to go forward. So this is kind of the only way I know currently. Maybe there is another method, but this was a hard question, and the answer is A.